Welcome to microprocessor and microcontrollers. In this lecture, I am going to explain about memory segmentation of 8086 microprocessor. So before going to that, let us see the software or programming model of 8086 microprocessor. It has this microprocessor has 14 16-bit registers, and this is the memory capacity of 8086 microprocessor, external memory capacity, and the starting and ending addresses of the memory is like this. And 8086 microprocessor supports 2 power 16 IO ports. This is the IO address space. So coming to memory segmentation, so as we discussed in previous lectures, that is in the architecture, 8086 uses segmentation. In this segmentation, what we are going to do is the complete memory is divided into fixed size of segments. Each segment size is 64 kilobytes, and the segment is addressed by using a segment register, right? So here in 8086, the 8086 microprocessor cannot operate or cannot access whole 1 MB memory at a time. It can't work with all the segments. So here, at any given time, the 8086 microprocessor works with 4 segments at any time, 4 segments. And coming to, for we have 4 segments, that's why 8086 microprocessor has 4 segment registers to hold the starting address of each and every segment, right? So here the segment registers holds the starting address of, that is starting 16 most significant 16 bits of the starting address of the address. That's important, right? So here the 64 KB logical segment can be located anywhere in the 1 MB memory. We can locate anywhere. Coming to the diagram, this diagram represents the memory segmentation of 8086 microprocessor. Here physical address is, here you can see physical address is in 20 bits. Physical address is in 20 bits. Each and every segment has a bottom of the segment and top of the segment, right? The bottom of the segment is stored in particular segment register. For example, ES, it has a starting address of 70,000. So 7,000, that is most significant 16 bits. These are the most significant 16 bits are stored in ES register. Likewise, CS, SS, DS, right? That is upper 16 bits of starting address of a segment is stored in these registers. Each and every segment which is having a maximum size of segment is 64 kilobytes, because the offset address of the segment is 16 bits. 2 power 16 is equal to 64 kilobytes. So coming to the, here we have segment S, code segment, different segments. Why we are segmenting? What is the purpose of segments? Coming to code segment, the code segment is used to store the program, all the instructions to perform a task. And the code segment registers is used to define the starting address of a code segment. And here the instruction pointer will store the, or points the particular address in the code segment, right? Here of IP, instruction pointer, stores the or defines the offset address of a code segment, right? So here code segment stores all the instructions, right? Coming to the data, the data segment is used to store the data and constants of the program that is required to execute the program. That means the code segment are used to store the data required to execute that program. Okay, so the data segment register will defines the starting address of the data segment, and the offset address of the data segment is stored in source index register. Right? And here one more point. The data segment, the offset address of the data segment is defaultly stored in source index registers, and SI, DX, BP registers also we can use it to store offset address of a data segment. That is, and coming to the extra segment. So extra segment is it is a extra segment. It is extension of the data segment, right? It is the extension of the data segment, and this segment is used in string operations. The source string will be stored in data segment. The destination string will be stored in extra segment. So the extra segment register will defines the starting address of a extra segment. Coming to the stack. So here in 8086 microprocessor, it uses a stack memory. It is in last in first out fashion. So here the purpose of stack is used to store the written address of the program and the temporary results. Okay, temporary results and some variables constants in stack. So while executing the microprocessor, while executing the program, it will be interrupted by others, peripherals or other requests. So at the time, it will process the interrupt request, or it will process the subprogram, and it will come back to the main program, and it resumes the program execution. So to resume the program execution, the the 8086 microprocessor will store the written address of the main program in stack. So here the stack segment register will define the starting address of a stack segment, and the offset address of the stack segment is defaultly stored in stack pointer, that is we call it as top of the stack. See, for example, here coming to this memory segmentation, there are some specific points. Those are the starting address of a segment may be assigned as 0. That is, starting address of the segment may be assigned as 000h to f00h. That is the starting address of the segment. This is a condition, and this address must be divisible by 16. And the offset address range is from 000 to FFFFF, because it is a 16 bits address. That's why this is the address. And so the physical address range is 000h to FFFFH. And coming to the segments, here we see in the so in the memory segmentation, we have seen different segments. Yes. So this diagram shows what. Here you can see code segment 1 and code segment 2. The code segment 1 has a starting address, and if you see the offset address of that one is 0002 FFF, that is 64 kilobytes, and in between two segments there is a space, empty space, and the starting address of code segment 2 is 25000. Okay, and the starting address of code segment 1 is 1000. So the ending address of code segment 1 is 14Fs, and the ending address of second segment is 1 2. So 25F 2F 25000 plus FFF, then we'll get a different address. So that is, here these two segments are not overlapped, not overlapped. Okay, so coming to another example. So these two are here. The code segment 1 is code segment 2 are overlapped. Let us see. The code segment 1 is having a starting address of 1000, and code segment 2 has a starting address of 1A00. So here from 1A01 to FFF, that is 1FFF, 1A00, 1A010 to 1FFF. So these addresses are in segment 1 and segment 2. So this area we call it as overlap. Overlap. What happens to overlapping? If we store in these locations, okay, if we store the contents, if we first store in code segment 1, after some time in the same locations, if you think it is a segment 2, and if we store in that segment 2, then what happens? The contents already stored in code segment 1 will be overwritten. We lost the contents. We lost. That is the problem with. So rules for segmentation here is segmentation process follows some rules. What is the first one is the starting address of a segment should be such that it can be evenly divided by 16. That is the first one. And second one is the minimum size of segment can be 16 bytes, and the maximum size of segment can be 64 kilobytes. So for example, like this is linear address and segmented address. So coming to the advantages of memory segmentation, here the 8086 uses two 16-bit addresses, segment address and offset address. We call it as a logical address, that to access a segment. So that's why segment address and offset address is 16-bit, but 8086 microprocessor has 20-bit address. The generation will take care of address generation will take care of BAU, right? So it provides separate memory areas for program data and stack. There is a separate program for program code segment is there, data for data segment is there, stack for stack segment is there, and which allows what protection. The data and program will not mix, right? Protection is there, and provision for relocation. That is, we can store anywhere in the 1 MB memory, right? And allows the processor to access the data from memory easily, fastly, which increases the speed of operation, right? Speed of operation. This is coming to the 20-bit physical address calculation. We have an offset address 16-bit and segment address 16-bit. The BAU will shift segment register contents to left 4 bits, and it will add 4 zeros, and this is summer. Okay, we'll get 90-bit address, 20-bit address. So this already we have discussed this one in earlier. For example, if CS is equal to 20,000 and IP is equal to 5678H, then physical address will be 25678H. This also shows, this diagram also shows the physical address calculation. Okay, so this is all about memory segmentation and 20-bit physical address calculation in 8086 microprocessor.